Welcome students. Today we are going to start some questions on symmetric anti-symmetric matrix. Now this is exercise 3.3 NCRT. So we already know that symmetric matrix, any matrix can be symmetric. For the uh, symmetric matrix, if the matrix A is equal to transpose of a matrix, then it is called symmetric, and anti-symmetric or skew-symmetric. For the skew-symmetric matrix, we should have A is equal to minus transpose of A. So now in this exercise, we have given a matrix and we have to convert into sum of symmetric and anti-symmetric matrix. So we know that any matrix can be written in the sum of the symmetric and anti-symmetric. For it, half A plus A dash plus half A minus A dash. So any matrix can be written in this format. The first term is for the symmetric, it will be for the symmetric matrix, and second half A minus A dash will be for skew symmetric matrix. Let us do one question, sir. How to convert a matrix into sum of symmetric and skew symmetric matrix. Let us do problem number 7. NCRT problem question number first part of 7. So there is a matrix. Show that the matrix A is a symmetric matrix. Now in the 7th part A, we have given a matrix A whose element are 1 minus A, 1 minus 1 5, and second column element minus 1 2 and 1, and third column element is 5 1 3. We have to prove that this is a symmetric. Is this matrix symmetric or not? So for finding whether it is symmetric or not symmetric, we have to find the value of transpose of A. For the transpose of A, we have to interchange column to row and row to column. Now first row will be our A minus A will be our first column. A, this is A minus 1 and 5, second row minus 1 2 and 1, and third row becomes our third column 5 1 3. So look at A transpose. Look at A transpose. Its value is the same as that of the matrix of A. So we have proved that if A dash is equal to A by the properties of these ones, and then matrix A will be symmetric. So we can say that A is a symmetric matrix. Symmetric matrix. Same way in the second part, how to second one we have 7th way, so that this matrix is a skew symmetric matrix. Matrix A is given 0 minus 1, its element is 0 minus 1 1. This is the first column element, and second column element 1 0 1 0 minus 1, and third column minus 1 1 and 0. So this is the entries of the matrix of A. We have to prove that it is a skew symmetric matrix. For skew symmetric matrix, we have to prove that A is equal to minus A transpose. So we know that for the skew symmetric means one important property is the diagonal element should be 0, because in skew symmetric matrix every element ijth element should be minus jith. So for the diagonal element this is 1 1 2 2 and 3 3. So for I and j will be should be equal to, for I equal to j for the diagonal element, diagonal entry. So therefore here aii should be minus aii. Okay, so diagonal element a11 I, if I equal to 1, so it becomes 1 1 minus 1 1. If you solve this ones, minus aii goes in left hand side, it becomes 2 times of aii equal to 0. It means that aii equal to 0. In that case here I will be 1 2 and 3. So for the diagonal element 1 2 and 3 both should be the same ones. So diagonal element here is obviously the same ones. Now let us do the transpose of a. This is a transpose of a will be here. So this is first row, this is first row become first column, 0 1 minus 1, 0 1 and minus 1, and this is second row will be minus 1 0 and 1, and this is third row will be third column 1 minus 1 and 0. If I bring minus is out common from here, so if I bring minus outside of this one, so it becomes minus. So we have to multiply it. We have taken some minus each element of this matrix A transpose, because in if you multiply it, yeah, if you bring something from inside of the matrix, so you have to take from each entry for each element. So to minus, so either you take you multiplied each one by minus 1. So I have taken minus first column, minus first column. If you take minus, so it becomes first row becomes 0, and this is plus 1 and this is minus 1, and second row becomes minus 1 0, and this becomes minus minus plus minus plus 0. So just multiply each entries of the minus. If you take minus outside, you multiply each entries by minus 1. So this is 1 minus 1 and 0. So look at inside of this matrix A, you will see this will be A. So this will be minus is outside, it becomes minus A. So we have proved that transpose of matrix A is equal to minus of A. So A is this proves that A is a skew symmetric matrix. A is skew or anti will be the same. Skew matrix, symmetric matrix. Now question number 10, express the following matrix as the sum of symmetric and skew symmetric matrix. Here question number 10. So in the question number 10 we have given a matrix. We already know how to convert matrix into skew symmetric plus symmetric matrix. Let us suppose question number 10, first part of the question number 10, we have. So this is a square matrix of order 2, 3 5 minus 1. First row element 3 5, second row element 1 minus 1. So this is a square matrix of order 2 cross 2 matrix. So for the A transpose of this matrix will be 3 5, first row becomes first column and second row becomes second column. Yes, this is our transpose of A. We already know that any matrix can be written half symmetric matrix A plus A transpose and plus half A minus A dash. So if you simplify this one, if you add these two, will come A. Now symmetric matrix will be half A plus A. Now for the symmetric matrix, matrix here will be just half A plus A dash. A dash means it is a transpose. So just adding the corresponding terms, if I put the value of A and A here, half A should be multiplied both ones. So half, if you put the value 3 5 1 minus 1 plus taken a brackets, half is just outside of this one, so I have taken a curly bracket. Yeah, we have to multiply here half A and half A dash. We can do this so now second one is A transpose. A transpose has the value 3 5 first column element, second column element 1 minus 1. So now just bring in the bracket. So now if you add and divide by 2, so 3 plus 3 will be 6 and 5 plus 1 is 6, 1 plus 5 is 6, minus 1 minus 1 minus 2. So we have outside is half, so each entity should be divided by 2. 6 by 2 is 3 here, 6 by 3 is 3, and 6 by 3 is also 3, 6 by 2 is also 3, minus 2 by 2 is minus 1. So this is the value of this will be our symmetric matrix. Now second term we need is skew symmetric. This is half A minus B is skew symmetric. For skew symmetric matrix we should have half A minus A transpose. So just put here minus and solve it. Yes, this will be taken in the curly bracket, and first matrix is 3 5 3 5 1 minus 1 minus A transpose 3 5 second column 1 minus 1 and bring it in the curly bracket. So now if I simplify this one, so here 3 minus 3 will be 0 and 5 minus 1 is 4 and 1 minus 5 is minus 4 and minus 1 minus minus plus, it will become 0. So minus here minus and minus outside is minus, so it becomes minus 1 plus 1, it comes out 0. So now it becomes, yes, should be in the square bracket. So this is our skew symmetric matrix. So any matrix can be written in the sum of the symmetric and skew symmetric matrix. Now next we do 3 by 3 matrix, second part of question number 10. Yes, let us complete this. Therefore matrix A here can be written matrix A. We have written matrix A in this format. 3 we have finally 3 5 3 5 1 minus 1. This is matrix A. Will be sum of symmetric plus skew symmetric matrix. This is 3 3 3 3 and 3 minus 1 second element 3 minus 1 and finally skew symmetric matrix will be this one 0 minus 4 0 minus 4 and 4 and 0. So we have converts a matrix. This is matrix A and this is skew symmetric matrix. This is symmetric and this is skew symmetric. Now this is matrix A. We have to convert into sum of skew matrix and symmetric. Now this matrix A will be equal to half A plus A transpose. This is a symmetric matrix and plus half A minus A transpose. A minus A transpose. This will be skew symmetric matrix. Let us do first part of this ones. Find the transpose of this A. Now transpose of A will be, this is a square matrix of order 3. So first row, this is first row becomes our first column. So 6 minus 2 and second row minus 2 3 minus 1 and third row becomes 2 minus 1 and 3. This is our third row. So now this is the transpose of matrix A. Now let us do first part, half A plus A dash. So we have to add, if I do directly, so here for finding first part half, this is the symmetric matrix will be first one. Symmetric matrix will be half A plus A dash. A plus A transpose will be this one. Now calculate this one, half A plus A transpose will be so half is outside, we just adding these two, it's 6 plus 6. Half is outside, just adding the entries of corresponding entries. Now 6 plus 6 will be 12 and here minus 2 plus minus 2. Minus 2 plus minus 2 will be minus 2 comes out minus 4. So this entry will be minus 4 and 2 plus 2 will be 4 and here minus 2 plus minus 2 and plus minus 2 minus 4 and next entry 3 plus 3 will be 6 and minus 1 plus minus 1 will be minus 2 and third row first row this is a first row, this entry is first row, first row third column. 3 plus 2 is 4 and minus 1 plus minus 1 will be minus 2 and here 3 plus 3 will be 6. So now it is our symmetric matrix. You should have divide each entries by 2. Now if I divide each entries inside of the matrix by 2, it comes out 12 by 6. 6 minus 2 dividing each entry by 2 and this is minus 2 and this is 3 and this will be minus 1 and this will be 4 by 2 is 2 and minus 2 by 2 is minus 1, 6 by 2 is 3. So this is our symmetric matrix. Now let us do skew symmetric matrix. This is the another part. So we have to calculate skew symmetric matrix. Skew symmetric matrix will be half A minus A transpose. You just taken half outside of this one. We do 6 minus 6 0 and minus 2 Now outside is minus 2 minus 2. What comes out? Minus 2 minus minus 2. It comes out minus 2 minus minus plus. This entry becomes 0. Now 0 and 2 minus 2 will be 0 again. And next one, same thing, minus 2 will be 0. And 2 minus 2 will be 0. And 3 minus 3 will be 0 here. And minus 1 will be 0. And same thing, minus 1 and this. Minus and minus, again 0. And 3 minus 3 will be 0. It means that each entry comes out 0. Yes, if you divide, this becomes half. 0 by 2. 0 by 2 will be 0. Each entry comes out 0. This is 0 matrix. This comes out 0. Skew symmetric matrix comes out here is 0. Yes, 6 minus 2 minus 2 3 minus. Yes. So the reason is that skew symmetric matrix comes out 0 matrix because here A is already a A is already a transpose. A matrix A is already a symmetric matrix. Symmetric matrix, that's why our skew symmetric matrix comes out a 0 matrix. This becomes a 0 matrix because here A and A are the both. A is equal to A transpose. That's why this terms becomes a 0. So now our matrix A will be sum of these two matrices. Okay, this matrix and this matrix. Now question number 10, third part of question number 10, this is matrix A. So we have to find out this matrix A is the sum of the symmetric and anti-symmetric. We already know that any matrix can be written in this format. Half, this is the symmetric part, A plus A transpose, and plus half, and this is a skew symmetric matrix. So first we find a transpose of matrix A. Right, so transpose will be here. First row becomes 3 3 minus 1, first column, and second row minus 2, this is minus 2 and minus 2, and this is 1, and third row minus 4 minus 5 and 2. This is our third row, and close it in the square bracket. Now first we find A plus A transpose, sum of these. So just A plus A transpose, A plus A transpose will be just half of this one, outside is half. If I calculate this one, so this is the symmetric matrix, it will be the symmetric matrix. Symmetric matrix. Yes, so this is our symmetric matrix. Let us do this value comes out, half is outside. We do just adding directly, 3 plus 3 will be 6, and this is the first column element. 3 plus 3 is 6, minus 2, and minus 2 plus 3 will be plus 1, and minus 4, and this is minus 4, outside is it comes out minus 4, minus 1 will be minus 5. So here this entry will be minus 5, and like 3 plus minus 2, 3 plus this entry is minus 2 comes out 3 minus 2 will be 1. So this entry is 1, and similarly minus 2 plus. So this entry minus 2, this is also minus 2, minus 2 and minus 2, and minus by bracket, open the bracket, and it comes out minus 4. So now this entry should be minus 4, and here minus 5 and plus 1, minus 5 plus 1 minus 4, and here minus 1 plus minus 4 will be minus 5. This entry is minus 5, and 1 plus minus 1, 1 plus minus 5 will be 1 minus 5, and this is minus 4. This is minus 4, and 2 plus 2, 2 plus 2 will be 4. So this is half of this matrix. Divide each entry by half. 6 by 2 is 3, and this is 1 by 2, this is a fraction, and minus 5 and 2, this would be in fraction, and 1 by 2 is here, second row element. Minus 4 to similarly minus 4 divided by 2 is minus 2, minus 5 divided by, and minus 4 divided by minus 2, and last entry 4 divided by 2 will be 2. So if I write this in this format, so this will be our symmetric matrix. Let us do skew symmetric matrix. So for skew, this will be our skew symmetric matrix. Half A minus A dash is our skew symmetric matrix. Now finally it becomes we have to subtract 3 minus 3 will be 0, and here minus 2 minus 3, minus 2 minus 2 minus 3 will be minus 5, minus 4 and minus 4 and minus 1. So it comes out minus 4, and minus will be plus 1. It would be minus 3. Minus 3 this entry, and similarly 3 plus minus 2. 3 plus minus 2 will be 3 minus 2, it will be 1. This is 1. Similarly minus 2 minus 2, minus 2 outside is minus 2, same thing. Minus 2 we are subtracting minus 2. So minus 2, if I open the bracket, minus plus, so this entry becomes 0. And similarly minus 5 minus 1 minus 6, and minus 1 plus minus 1 minus 4, so minus 1 plus 4 will be 3, and 1 minus 5, 1 minus 5, it will be 1 plus 5, 1 plus 5 is 6, and 2 minus 2 will be 0. This is the last entry, and write in square bracket. Now divide by half. If I divide by half, so 0 by 2 is 0, and 1 by 2, and 3 by 2, minus 5 by 2, and 0 by 2 will be 0, 6 by 2 will be 3, minus 3 by 2, minus 3 by 2, and here minus 6 by 2 is minus 3, 0 by 2 will be 0. So now this is our skew symmetric matrix. So we can write this, this is suppose P, and this becomes let us suppose Q. So any matrix, therefore we have proved that A is P plus Q. So any matrix can be written some of the symmetric and skew symmetric matrix. Now invertible matrix, any square matrix can have a inverse of inverse. Now invertible matrix, so its definition is, if A is a square matrix of order, let us suppose of order means order will be m cross m, then if there exists another matrix if there exists another matrix of order also m, such that AB is equal to BA and also comes out identity matrix. So then A is called, or B is called, the inverse of, then B is called inverse of A. Inverse also of A. We would also say that A B the inverse of A, similarly A the inverse of A, and also we can say A will be the inverse of B. So another things about the invertible matrix. So first, no rectangular matrix can have inverse. No rectangular matrix can have inverse. Its reason is that for AB and BA should only defined only for the square matrix. So in case of the rectangular matrix, it is not possible. So AB cannot be equal to BA. So that's why we need only the square matrix of order only the square matrix. And second point about the invertible matrix is that we can write AB is equal to BA and is equal to I is the identity matrix. In that case, if the order of A and B are M, and I should also be the order M. I is the identity matrix of order M. Order is M. Now let us do some problems from before that we have some important theorems here. Now first theorem, inverse of a matrix will be unique. So there will be no two inverse of matrix of A. Yeah, we can say that there is only single. Uniqueness of the inverse means there would be only one inverse of any matrix. So uniqueness is known as inverse of a square matrix. The theorem is inverse of a square matrix if exists will be unique. If exists will be unique. Now unique means it has only one. It has only one square matrix. Let us do suppose B the transpose of B the inverse of A, then AB is equal to BA is equal to I. Also we say that another matrix AC, C the inverse of A, then AC will be CA, and it is also identity matrix. So we can prove it here. B and C will be the same. B and C will be same. It only possible. So B and because inverse of any matrix will be only one inverse of a matrix will be there. Now another important property is here. Theorem number 2. This is our theorem number 1. Now theorem number 2. Now theorem number 2 is very important property here. So the inverse of here, very important property, inverse of product of two matrix will be just inverse of product of the inverse of the matrix B and A taken the reverse order. This is very important. It only possible A and B invertible matrix. So here A and B are invertible matrix. For invertible matrix there would be AB should be AB and AB B inverse or A inverse should be defined, and A and B should be square matrix. A and B are invertible matrix. This is invertible matrix. This is our miscellaneous exercise on chapter 3. Question number first. Question number first. If I read out this, if A and B are skew matrices, prove that AB minus BA is a skew symmetric matrix. So it is given that here the A and B are symmetric matrix. Symmetric matrices. So we have to prove that AB minus BJ is skew symmetric matrix. Let us do. We have to prove AB minus BA should be skew symmetric matrix. Skew symmetric matrix. Yes. So let us do mathematically this question. Now for the skew symmetric matrix, transpose of A, just finding the transpose of this one. So this is first apply the transpose difference of two matrices. AB and B are two different matrix. So just applying this transpose of AB minus transpose of BA. So now applying the transpose of AB. In transpose of AB, we know that B transpose, just order interchange. Here is order in interchange A transpose and B transpose. If I take minus outside of this one, so this becomes A dash B dash A transpose B transpose minus B transpose and A transpose. So here A and B are symmetric matrix, we know that A is transpose of A and B the transpose of A, because A and B are symmetric matrix. Therefore, replacing A transpose A and B transpose B and B and A. Look at this one. We have find the transpose of AB minus B is just negative of this one. It means that AB minus B. It proved that AB minus BA will be our skew symmetric matrix. Yes, this proved. Now similarly in the question number 2, second part, we have question number 2. In that part, same way we can do it. Question number 2. In question number 2, show that matrix B transpose AB, B transpose AB symmetric or skew symmetric according as A symmetric and skew symmetric. So it will be symmetrics. We have to prove that if A is symmetric, and another one, B transpose AB will be a skew symmetric matrix if A is skew. Okay, so let us solve it. So here just now first A is symmetric. If A is symmetric, then A will be transpose of A. So we have to find the transpose of this one, B transpose AB. If I do transpose this one, so we have by using the properties and the transpose of each entries and multiplied in the reverse order. First take the transpose of B, taken the transpose of B, it will be B dash, transpose of A dash, then double transpose of B will be B. So now according to question, transpose of A is A. Now this value becomes B transpose and A and B. So here we have proved that transpose of this matrix is again comes out this one. So it means that B transpose AB will be symmetric matrix. B transpose AB will be our symmetric matrix. So now in second part, if I say in the second part, if transpose of A is minus A, so we need to prove that B transpose AB will be skew symmetric matrix. Let us do the transpose of this multiplications, B transpose A and B as a whole. Now taken the transpose and multiplied in the reverse order. First take from the end entries B transpose, it is B transpose, then A transpose and B transpose, double transpose. Okay, if I do the transpose of B and twice, and it becomes matrix B. Now replacing transpose of minus A, if I replace this one and written in the bracket, now this minus 1 is an A scalar taken outside of this one. So therefore B transpose A and B. So here we have proved that transpose of B transpose AB is minus of this one. This is the properties of a skew symmetric matrix. That's why so here in that case B transpose AB is a skew symmetric matrix. This will be our skew symmetric matrix.